Good afternoon, everyone. My name is Marva, and I'm here today to talk to you about our paper, Neighborhoods, Directions, and Distances, looking at segmentation effects in a real-world city. So representations of environments are a result of a two-way interaction between the environment and the person who's experiencing and observing the environment. And we cannot really separate one from the other, as the environment comes with certain constraints and features, and that suggests certain relations to the observer, and the observer attends and organizes what they experience to form a mental image. And this is going to be a subjective experience of what the observer perceives, meaning that the representations of a given environment will likely vary significantly between different people. And if you're talking about a city environment where every citizen will have different associations, different strengths of associations that they've created depending on their memories and their explorations around the city, and maybe they have knowledge of certain areas more because they live there or work there and they travel between these areas more. So how do people spatially represent a complex, large-scale environment such as a city? So people have done a lot of thinking about this, and as a result of years of spatial cognition research, they think that mental representations of spatial information often have a hierarchical structure, meaning that we might be forming local maps that are connected in a graph or organized in a hierarchy. And we know this from cities, as they are often segmented into smaller regions called neighborhoods, and the boundaries of these neighborhoods can be defined by many different conditions, such as the main routes or streets, natural or man-made features, and history and character of the city as well. So before going into the cities, behavioral effects of segmentation have been observed in various different scales. And as an example, for example, we have vista spaces, like the room that we're currently in, where we can almost see everything from a single vantage point. And again, if we don't necessarily see it that way, we can see a lot of the objects with a minor amounts of locomotion. And they found that when these vista spaces were segmented, even by just strings on the floors, people estimated that distances between segments to be larger than within segment distances. And these errors are actually increased if people were told that they cannot cross the streets, meaning that the strings now constrain their movements. As virtual environment technology also became more widespread, people started studying segmentation effects in virtual towns as well. And they found that physical barriers to movement, such as a river that runs through the environment, stimulated segmentation effects, even if all the landmarks or target buildings were visible at all times. So looking at the environmental scale in a real life environment, people have previously studied university campuses and found that segmentations created by categorical conceptual categories cause distance errors between segments, but only for those who are familiar with the campus. And lastly, we also have the geographic scales, where they also found some distortions of directions and the position of US cities to conform with the state boundaries. So the previous work have shown behavioral effects at different scales, but what these studies haven't really touched on is the individual variation of how people see barriers in the real life, because not all barriers are equal. And so in this study, we will look at how different barriers, can be physical or notional barriers, affect people's segmentation and affect people's image of their city, and whether or not people endorsing them in their own use also has an effect on segmentation. So we thought Istanbul was the perfect city to study this. And that's because it is a transcontinental city with one half in Europe and the other half in Asia. And it's separated by the Bosphorus Strait, and it's bounded by two large bodies of water, the Black Sea in the north and the Sea of Marmara in the south. In addition to this very prominent barrier that divides east and west, it also has another smaller waterway called the Golden Horn on the European side. You can see right there. And it divides the European side into north and south of the Horn. So this is a smaller waterway, but it is an important geographical and historical feature because it defines the north border of the Old City, also known as Constantinople. So prior to our study, we wanted to have a better understanding of the mental segments that people might have. So what we did was we contacted 48 citizens of Istanbul and asked them to draw how they mentally segment the city on maps. And we overlaid these sketches on top of each other to see and extract the most commonly occurring segments. And we ended up with 4 different ways to segment the city of Istanbul for our study. So the first one here at the top is the 2-segment solution where people separate between Asia and Europe using the Bosphorus. The second one is a 3-segment solution where there is the Asia and Europe divide, but Europe is further divided using the Golden Horn. The third one is again another 3-segment solution. And again, we have the Asia and Europe sides, but we also see this boundary on the Asian side. Now, this boundary is not a physical barrier, but it is a more notional one, marking the 2 different communities and the social construct of these 2 neighborhoods or segments. And lastly, we have a 4th way of segmenting the region, the city, which has all of the subregions that I've just talked about. So then we picked 3 different landmarks from each of these subregions, and these were all historical spots that are very well known, or sports arenas in the city that are quite popular, excuse me. So during our actual study, the participants first picked their segmentation that they endorsed out of these 4 options. And they completed a series of distance estimation trials where they estimated the direct distance as the crow flies distance between the 2 landmarks that were presented to them. And to account for the differences in actual distances, we calculated the relative distance errors, which are the absolute value of the difference between actual direct distances and estimated distances divided by the actual distance. They also completed a direction estimation task where they were told to imagine that they were standing at the first landmark facing the second landmark, and they were asked to point to the third landmark in this orientation. And we calculated the pointing error between the pointing judgments of the participant and the actual direction. We also asked them a bunch of other questions and questionnaires and tasks that I won't talk about for the sake of time, and because the analysis is still continuing, but I can answer any questions during Q&A. So results. First, looking at the endorsed segmentation of our participants, you can see that the number of people that picked each of the different segmentations at the top in white. The main thing we see here is that this varies a lot between people. And it is interesting because Golden Horn is historically very important and famous, and is a geographical boundary that constrains movement across Europe. However, some people, for example, this group that only divides between Asia and Europe, and these people who have a 3-segment solution but only detailed in Asia, do not think that Golden Horn is that important for their mental image of the city. So what this really tells us is that we can't really assume that all boundaries are equal, and also there is a lot of variability. Okay, so let's start by looking at spatial judgments across Bosphorus. Since this is the most prominent way of segmenting the city, and it is a divide that was endorsed by everyone, supported by the preliminary study, and it is also a categorical segmentation because it is continental. So we will look at how direction and distance errors change across the Bosphorus between Europe and Asia. And just to give you an example, here's how a between trial looks like. You can see that one of the landmarks is on the European side, the other one is on the Asian side. And this is an example of a within trial where both the landmarks are on the European side, and we can also have this within trial where both landmarks are on the Asian side. So here we have the distance errors on the y-axis, and we separated the errors for between and within segments for the participants on the x-axis, and the dashed line marks 0, and it shows that all of our participants overestimated in general in their relative distance estimations, but this overestimation was more marked for between segment locations. So here we're seeing that the very salient Bosphorus barrier stimulated the behavioral segmentation effects by increasing the distance errors. So on this graph, we have the direction errors. Again, they're on the y-axis. And we can see the similar pattern here where the direction errors are larger between the segments compared to within segment judgments. So the takeaway from these two graphs, both the directions and distances, is that this major physical barrier that is also categorical because it divides between two continents showed the expected effects of segmentation. Now we're going to be looking at the Golden Horn and the segmentation across the Golden Horn. So the Golden Horn is a less marked boundary because it is a smaller waterway and it's not as categorical because the two sides of it is all in Europe, but it is important historically. And what we wanted to see here is if we would get the same effects of segmentation that we did with the Bosphorus Strait. So we wanted to see if people who endorsed a Europe segmentation differ from people who did not in their between and within segment errors. So we're comparing those who segmented Europe, which are the people who choose these two segmentation methods, because you can see that they both have the Golden Horn as a barrier. And we will compare them to people who did not segment Europe, which are the groups that are not highlighted in yellow. Okay, so here's what a between trial looks like for across Europe segmentation. As you can see, both the landmarks are in Europe, but one of them is on the north of the Horn and the other one is in the south. So this would be a between trial. And here's what a within trial would look like. As you can see, both the landmarks are on the north of the Horn. And this would also be a within trial if both were on the south of the Horn. So let's look at the findings, and I want to linger on this slide because it is an important one. So here we're looking at the distance errors on the y-axis again, and we separate between people who did not segment Europe and people who did segment Europe on the x-axis. And we see a very interesting finding here. Where if you segment Europe, you get the expected effect of segmentation there, driven along the Golden Horn, where you think the distances are longer. But if you did not segment Europe into two, that does not happen. So their choice of endorsements at the beginning were quite sensible in this case, because we see that the individual's conception of the environment can lead to these segmentation effects independent of that, the Bosphorus boundary. So we're seeing it on the Golden Horn as well. So looking at segmentation of Asia, and I already mentioned that this is not a physical barrier, it's a more notional one that segments for social characteristics of the communities of the two neighborhoods. And we're looking at people who segmented Asia, which would be the Asia detailed solution and the 4-segment solution. And we're comparing them to people who did not segment Asia into two. And again, here's an example of a between trial for Asia segmentation. As you can see, the two landmarks are divided by the barrier. And the within trial, they're both on one side of the barrier. So here we have, again, the distance errors on the y-axis, and we separate between people who did not segment Asia and who did segment Asia. And we don't see an interaction effect or a segmentation effect here, which becomes interesting when you compare it to the Europe finding, because this tells us that not all barriers are created equal, and individuals' conceptions of them and how this conceptions affects spatial judgments differ between notional and smaller physical boundaries, barriers. Right. So our conclusions, we show that there is variability in people's endorsed segmentation, and not only we observe behavioral segmentation effects with large prominent barrier, namely the Bosphorus, but we also saw that individuals' own endorsed image and their own conception of the environment can lead to this segmentation effects in smaller physical boundaries. And we also found that we found differences between segmentation effects between physical and notional barriers. Thank you.